a Q&A window. We have a few technical experts with us who've joined us today, and they would be happy to answer any questions you have throughout this presentation. We'll also reserve the last 10 to 15 minutes of this presentation remaining addressing any of the unanswered questions at that time, and we will do so just through the chat functionality. You should also see on your webinar console a list of resources. We've provided a couple of URLs we think you might find helpful throughout this presentation, and you can feel free to click on those whenever you like. You'll also see a survey window, and so once we're finished with today's presentation, we'd really appreciate any feedback you have on how you think we did today, how you enjoyed today's presentation, and any topic areas you were interested in learning more about, as this will really help us determine the sort of webinars we'll be putting out in the future. We also often get the question, will the slides from today's presentation be available afterwards? And the answer is unfortunately no, we are not able to send out the slides, but you will be getting an MP4 sent to you by email within 48 hours, so keep an eye out for that. I'm joined today by three presenters. Debbie Lyons, who is a Senior Product Marketing Manager, Travis Wright, Principal Program Manager, and Bob Ward, Principal PM Architect. So Debbie, whenever you are ready, I'd like to pass it off to you.
Thank you, Nicholas. At Microsoft Ignite, we announced a public preview of SQL Server 2019. SQL Server 2019 builds on a 25-year history of helping enterprises manage all of their relational data, whether that's operational data, business intelligence, or data warehousing. In the past few releases, SQL Server has gone beyond relational data by helping customers store and query graph data inside the SQL Server database, adding support for R and Python machine learning, and for the first time in SQL Server 2017, we made these capabilities available not just on Windows, but on Linux and Docker as well. SQL Server 2019 builds on all these releases and this great momentum by adding more mission-critical performance, security, and availability features to help our customers run their mission-critical workloads on SQL Server on Windows and Linux. We're also continuing to unite workloads, making everything built in our mantra, where we are adding now support for SQL Server and Spark together in SQL Server 2019, creating a unified data platform. SQL Server 2019, for the first time, will enable customers to query over relational and non-relational data in a single integrated solution using SQL Server. And through that, provide insights over all your data, simplifying big data management, giving your developers, analysts, and data engineers a single view into your data, structured and unstructured, and breaking down data silos and delivering one view across all of your data using data virtualization. Here to talk more about how that works, I'm going to turn it over to Travis.
Thanks, Debbie. We're really excited about SQL Server 2019 because we believe that it will help our customers integrate all of their data, manage all of their data, and analyze all of their data using a simplified tool set and deployment infrastructure that's all deployed as one combined solution. So let's dig into some of the details about what SQL Server 2019 will help you do. The first is integrating all of your data. And this really goes back to SQL Server 2016 when we first introduced the Polybase feature. Polybase allows you to create an external table over a big data cluster like Cloudera or Hortonworks so that you can query a table inside of SQL Server and have SQL Server turn around and go and get that data out of the HDFS in the Cloudera or Hortonworks cluster. And in SQL Server 2019, we're really expanding the capabilities of Polybase by introducing additional connectors to even more data sources. Those data sources include Oracle, Teradata, MongoDB, and cloud-based databases like Azure SQL Database, Data Warehouse, or even Cosmos DB. And this will enable you to define these external tables inside of SQL Server and query them just like you would any other table inside of SQL Server, join them with other tables inside of SQL Server, and then have SQL Server take care of the work of going and getting that data out of those external data sources and bringing it back to the application or the report that requested the data without you having to move the data through a typical ETL job. So that makes the data more timely. It reduces the amount of effort you have to spend building and maintaining ETL pipelines, and it also reduces the attack surface area of your data by keeping the data in one place. Now in SQL Server 2019, we're also introducing what we call big data clusters. And one of the features of big data clusters is that you can improve the performance of these types of data virtualization queries using external tables by caching the data in what we call a data pool. And a data pool is used to query the data out of the external data source, partition that data, and spread it across multiple SQL Server instances so that each SQL Server instance then has a partition of the data from the external data source. When we issue a query against that data, the filter and local aggregation part of the query happens in each of the SQL Server instances in the data pool in parallel, so you can parallelize and really scale out that portion of the query before the data is returned back to the master instance. Now, one of the things about the big data cluster is that we are going to be, for the first time ever, including HDFS and Spark in the box with SQL Server. And the entire thing is deployed as a single, deeply integrated solution that's provided by and supported by Microsoft. And this unified data platform of big data and relational data is deployed as Linux-based containers on top of Kubernetes. Kubernetes provides some really important value propositions as far as like the infrastructure that you deploy SQL Server and Spark together on. The first is that it makes it very fast to deploy. Because it's just based on containers, you simply have to pull down the images and spin up the containers. You can have a big data cluster setting up on your Kubernetes cluster in a matter of a few minutes. Secondly, it's all self-contained. That's one of the promises of containers, is that all of the software required is contained inside of those images, and it's further easy to update as you go along because you just simply download the new versions of the container images as Microsoft releases cumulative updates, and the control experience inside of the big data cluster will orchestrate a rolling upgrade of your software throughout the entire cluster. Using Kubernetes as the underlying infrastructure enables you to have a more scalable architecture for your big data cluster. It makes it easy for you to extend the storage capacity of your cluster by simply spinning up additional containers of HDFS. And it also makes it easy for you to elastically scale up and down the compute capacity or the storage capacity by adding or removing containers on top of Kubernetes. Now, one very important aspect of this architecture is that we're going to create what we call a shared data lake built on HDFS as the storage layer for a big data cluster. Then we'll have Spark and SQL Server instances co-located on every HDFS data node to make accessing that data super fast and secure. So you can kind of think about the architecture as looking something like this. First, we have a storage pool, which is a set of pods that each have HDFS, Spark, and SQL inside of them. And that storage pool can be as big or as small as your storage and compute capacity requires. And that sits on top of a number of Kubernetes nodes that act as the hosts for those pods. And then we have a SQL Server master instance up there at the top of the diagram. And all of your apps and BI and DBAs and that kind of thing are sitting on top of that SQL Server instance, and they interact with that SQL Server master instance just like they do any other SQL Server. You connect to it using the same application frameworks and tools that you use today. But now you'll have the ability to issue a query to that SQL Server master instance and query the data that resides in the HDFS through the SQL Server instances that are co-located with the data nodes. If you have a really big query that you want to run, though, you can introduce what we call a compute pool. And a compute pool is a set of SQL Server instances that work together to process the data. Each SQL Server instance in a compute pool reads in a partition of the data from the external data source, like HDFS in this case. And then the SQL Server instances in the compute pool work together to do cross-partition aggregation and shuffling of the data before sending it back up to the master instance. You can use compute pools over other types of external data sources like Oracle, Teradata, MongoDB, and so on, using those poly-based connectors we discussed earlier. You can also put a compute pool over a data pool. So in this pattern, the data is cached from an external data source or from an IoT data stream, for example, in a partitioned store across those multiple SQL Server instances in the data pool. And when we issue a query in this pattern, the local filters and aggregations happen in parallel across each of the instances in the data pool. And then the compute pool sitting on top of that does the cross-partition aggregation and shuffling of the data before returning it to the master. Now, to provide really a truly unified data platform, we need to unify the experiences of how you manage your relational data and your big data. To do that, Azure Data Studio is the new cross-operating system open source tool that you can use to manage both the SQL Server relational side as well as now the SQL Server HDFS and Spark side of things in one tool. And this tool provides you a notebook experience that you'll be able to use to execute Spark jobs using Python or Scala or R. And you'll also be able to run T-SQL queries, again, in one tool. We'll also provide a unified administrative experience by providing a control plane within this big data cluster. And the control plane will have agents that are spread across the infrastructure to collect monitoring data and logs back to Elasticsearch and InfluxDB. And then we have an administrator portal that sits on top of that where you can view performance monitoring dashboards, do log analytics with Kibana, and you can scale up and scale down your cluster, manage security, and view the current state of things as well as alerts and so on. And so this one unified management experience for your SQL Server relational side and your SQL Server big data side can all be managed in this one admin portal, and it's deployed as part of a big data cluster. And because everything is deployed on top of Kubernetes, including the management experience, regardless of where you deploy a SQL Server big data cluster, whether it's on-premises in your own hardware, or it's running on top of VMs in the cloud, or even a managed Kubernetes service like Azure Kubernetes Service, you get a consistent management experience regardless of where you go. And we provide APIs and command line utilities that make it easy for you to operationalize this and automate things around this infrastructure. Lastly, SQL Server 2019 Big Data Clusters provide you a unified platform for AI. Because SQL Server and Spark and HDFS are brought together, we can help you build an entire pipeline for doing your machine learning and AI. That starts with doing things like Spark streaming or using SQL Server integration services to ingest data. You can then store that data in data pools, in the SQL Server master instance in relational form, or you can store it in HDFS in structured and unstructured forms. When it comes time to prep your data, that's where Spark comes in. You can leverage the distributed compute ability of Spark to do the data preparation tasks using any language, whether it's Python or Spark or Scala or Java. And then you can use Spark ML or SQL Server machine learning services to train your models. And then when it comes time to operationalize those models, you can operationalize them in various ways. For example, you could operationalize a model as part of a stored procedure in SQL Server master instance using the native T-SQL predict function. Or we will also provide an experience where you can take a model and using our toolkit, wrap that model in a RESTful API that can then be deployed as a container on top of the big data cluster on Kubernetes. And that way, your applications can simply call that REST API and operationalize the model that way. So now let's do a demo of this unified data platform. Okay, so here I am in Azure Data Studio. And you can see over here in Azure Data Studio that I'm connected to SQL Server. And you can see my databases inside of the SQL Server. This is the master instance of SQL Server. And I'm also connected to the Knox endpoint here where I have access to Spark and HDFS, which we'll see in a minute. First, what I want to show you is how easy it is to create an external table inside of SQL Server over Oracle. So to do that, I'll start up the external table wizard. And I'll choose the Oracle data source. And we'll add additional data source types over here over time. Click Next. I already have a database master key, so I'm going to skip that. And here I just give my external data source a name, like Oracle table. I provide the server name to connect to. provide the database name, and I can choose a credential to connect as. Once I do that, I can now browse the schema on that external Oracle server and view the tables that are available for me to create external tables over. And I can select, for example, this HR inventory table, and I can even view the schema of that table right here, and I can choose to do column mapping if I wanted to, for example, or change the name of the external table that will be created. Once I've done that, I can create that table, and if I go back to my databases here, expand sales, expand tables, refresh. Okay, so now I can scroll down here and I can right-click on the Oracle Inventory external table and do a select 1000 from that. There you can see that we actually go and get the data out of Oracle at the time that your query is issued. So the data is not actually inside of SQL Server, it's only retrieved at the time we run the query. Now let's take a look at how we can create a table over some files in HDFS. So here you can see where I can browse the HDFS inside of the big data cluster, and you can see that I have a directory here called Clickstream Data that has a CSV file in it with millions of records of Clickstream data about a website. To create this external table, I first run this part of the query, which will use the sales database and then create an external table and define the on-read schema of the table that should be created. And then it uses the data source for querying data out of HDFS. And I specify that the location of this is the Clickstream Data directory that you see in HDFS here. Now that my table is created, I can run another query over this data. And what this query does is it joins together the data that exists inside of the external table called Clickstream and a table that exists inside of the SQL Server master instance. So this makes it very easy for you, just like you would any other tables, to combine data that exists inside of HDFS with data that exists inside of SQL Server. Well, lastly now, I want to show you the notebook experience. Here I have a notebook which is connected to my Knox endpoint so that I can submit Spark jobs into the Spark side of a SQL Server 2019 big data cluster. This notebook is going to take a look at a CSV file that has some data about diabetes in it. So this has some information about the biostats of different patients and whether or not they have diabetes. So to begin analyzing this data inside of a notebook, I first read the CSV data file into a data frame, and then we can see what that data looks like here inside of the notebook. Next, I can create a temporary view over that data, so we can now start to query that data using SQL syntax. So here we're executing a Spark SQL query over that data, and this should look pretty familiar to anybody that's used to using SQL to run SQL queries. So now we can see the correlation of age and insulin levels amongst these patients, right? And we can see there's not really a strong correlation between insulin level and age. So that's not really going to help us figure out whether or not somebody has diabetes or not, or is likely to have diabetes. So now let's use Spark machine learning to further analyze this data using machine learning to help us out. The first step here then is to featureize this data into these different features now. And now that we've featureized this, we can use the k-means algorithm to create some classifications of this data. And then we can use those classifications to help predict whether or not somebody is likely to have diabetes based on these different features. We can see here, for example, that in fact, whether or not somebody has a relatively high level of a BMI, like a 35, is likely to have diabetes. Somebody that has a relatively low BMI is less likely to have diabetes. And then we can also do, an analysis by a different feature, like the number of pregnancies that the patient has had. And so in this case, you can see that the number of pregnancies that somebody has had is not surprisingly not a good indicator of whether or not somebody has diabetes. Okay, so now you've seen the notebook experience inside of Azure Data Studio. You can see how easy it is to manage both the SQL Server relational database side of things, as well as using Spark and notebooks to analyze the data that exists on the big data side of things inside of the same SQL Server 2019 cluster using Azure Data Studio. So SQL Server 2019 really covers three different things as part of this big data clusters approach. The first is that it enables you to do data virtualization over external data sources like Oracle, Teradata, as well as HDFS outside of the big data cluster, or HDFS that's packaged in the box with the SQL Server 2019 big data cluster. It also provides a shared data lake built on top of HDFS that you can access using either SQL Server or Spark, using the tools and application libraries that are familiar to you. And it provides a complete AI platform for you to ingest your data, prep your data, train your models, and then score against those models, all within one SQL Server 2019 big data cluster. So now let's hand it off to Bob to talk about all the other things that we're doing inside of SQL Server 2019.
Thank you, Travis. I was at Microsoft Ignite, and quite frankly, we really shocked the industry with the capabilities Travis just talked about. I mean, including Apache Spark, HDFS, those kind of technologies with SQL Server together is really kind of a groundbreaking thing. And for a lot of things that Travis showed you, SQL Server is the core of that, the SQL Server engine, and it really is the horsepower that drives even some of the scenarios that he just talked about. For example, our data pools take advantage of technologies like column store. Our chief release architect, Connor Cunningham, always tells me that performance, security, and availability are the meat and potatoes of SQL Server, the heart of our SQL Server engine. And in SQL Server 2019, we definitely have made enhancements in each of these areas based on even the great work we've already delivered in 2016 and 17 with features like query store, automatic tuning, dynamic data masking, and read scale availability groups. Let's spend a little bit of time going into each of these areas and see what in SQL Server 2019 we delivered on. It's one thing to help you build an application that is fast and scalable, and the SQL Server engine has those capabilities to ensure you can get up to speed, build your application and get great performance. But staying fast is another thing. And so, what we try to do in SQL 2019, based on some work we did in 17, is build query processing capabilities that adapt, recognize new hardware patterns, and keep you fast. And in fact, I kind of like to think of this as an intelligent database system. What you see on the right here is a tree and a suite, a feature family of something we call intelligent query processing based on the work we did in SQL 17 on something called adaptive query processing. And the query patterns in bold here are the new patterns in SQL 19 that we're delivering on. And the thinking here is that we want to build a query processor that will not only build query plans that adapt to your data, but also adapt based on execution you've already done, so you can spend a lot less time trying to tune query plans. A great example is a query pattern a lot of people have run for years, and that's table variables. But they struggled with that because of the way we estimate cardinality execution statistics for table variables. And so now we use a concept called deferred compilation so that without any changes in your application, you simply move to the new compatibility level of SQL 19, and you get some amazing performance gains now being able to use table variables in a new way. No knobs, no trace flags, all built into the engine. And so intelligent query processing has several different opportunities that you can take advantage of. And again, you don't do any switches. You just go to the new compatibility level, and your query plans can now take advantage of this capability. We also want to take advantage of great hardware innovations. So you think of persistent memory NVDIMM type technology. SQL Server now built into the engine can actually recognize those patterns, bypass the I/O stack, and deliver new I/O performance for your workloads built into the engine itself. And you can count on us being able to look at those kind of technologies down the road and innovate and do new exciting things to even boost performance further. But if you look at the point in the middle here about lightweight query profiling, a lot of our customers, we have great diagnostics in SQL Server Engine. I believe we've done it over the years. We've been innovative in that space. But trying to get actual performance insights anytime, anywhere, especially for queries in flight or in progress for a running server, has been difficult. Sometimes the query will have to complete, you'll have to turn on some diagnostics or trace flags, and then at some point go back and try to figure out the problem. We introduced a feature called lightweight query profiling in previous versions of SQL Server, but those required trace flags to turn those on. We've now been able to determine that with little or no overhead to execution and performance of your SQL Server queries, this just runs by default. Imagine going to a SQL Server, taking a look at queries that are in flight or in progress, and being able to debug the query plans live and see exactly what they're doing to make determinations of what kind of tuning you need next. So that's just a flavor of what we're doing in the performance space. If you think about security, We are known as the least vulnerable database in the industry for the last decade, but we also believe in creating great features that help you keep your data secure. And Always Encrypted is a technology that we shipped in SQL 16, and we want to keep enhancing those capabilities. One of the limitations of Always Encrypted is the fact that data has to be unencrypted always on the client side. It provides a great separations of duties and doesn't allow access to even database administrators, but it prevented rich query patterns like clauses and so forth. And we've now enhanced that using a technique called secure enclaves, whether that's a virtualization or built into hardware chip, where the data can actually be unencrypted on the server itself within SQL Server, but not available and seen by high-privileged users like database administrators. So now, Always Encrypted is more of a complete solution, allowing you to do with rich query patterns, but still use the full functionality of an end-to-end encryption scheme. In SQL 17 timeframe, we introduced tooling that allows you to do data classification for GDPR scenarios, where we'd use our tools like Management Studio for you to label your data and then go run reports on those classifications. In SQL 19, we now provide the capability where that classification is built into system tables, into the metadata of the SQL engine through T-SQL syntaxes. And what's really powerful about that is auditing is now built in. You can go label your data for privacy or GDPR classification reasons, and now you can audit which queries touch that labeled data. So we believe that's a new groundbreaking feature and feature set that will help customers looking for compliance scenarios in their business and in their industry. We know certificate management has been a difficult task for many people with SQL Server. If you think of scenarios where you have to manage certificates across machines like availability groups or failover cluster instance scenarios, we know that's difficult. So we've now baked in certificate management into SQL Configuration Manager. So now those scenarios are much easier for you. And then finally, you think of the area of availability, always on availability groups being our flagship feature for SQL Server HADR. And we've made enhancements in the area in SQL 19. As an example, we've offered now what we call primary connection redirection in scenarios where you can't deploy listeners so that your application can always be connected to the primary no matter where failover occurs. We also believe in enhancing index scenarios. We've done resumable online index rebuilds, online index creation in several releases, and now we enhance that feature set even further, including the ability to do online cluster column store index rebuilds online for your application needs. One of the patterns for availability, though, that we find very interesting, and a pattern you saw in the big data clusters and something going forward for us, is the taking advantage of containers and environments like Kubernetes. And so we are proud to announce in SQL 19 the functionality of doing availability groups on Kubernetes. Take a look at this diagram right here to give you an idea of what I mean. In a Kubernetes cluster, you have a concept called a node and a pod, and we now support the ability to deploy a concept called an operator. That operator allows you, once you deploy it, to automatically provision a series of SQL Server instances in containers with something called an AG agent in an availability group automatically. Think of that as a very simplified deployment experience and configuration experience for SQL Server availability groups. You then go in and add your database to the primary, and now using direct seeding, we will now populate your replicas, and all of a sudden, you're up and running now in a complete availability group solution with replicas. Now, you want to be able to connect your application to this, so Kubernetes provides a concept called a load balancer service endpoint. Think of this like a static IP address. Your primary app will connect to the load balancer, which is directly connected to your primary. In addition, you might want to do read-only scenarios where you look at read replicas. So you might have a reporting app using a different load balancer that's going to connect to these secondary replicas. So if we detect things like a pod goes down with your primary, using our AG agent containers built into this service, we will automatically detect, do a failover to the new primary, whereas the load balancer is now redirected from the primary app into your new primary replica. In addition, your primary replica is going to, when it comes back online, become a new secondary, so we're able to automatically redirect your secondary reporting app with load balancer right into the new secondary replica. We think this is groundbreaking because customers have discussed with us the difficulty in some cases of getting availability groups up and running and configured, and Kubernetes provides a whole new paradigm through the use of things like operators and load balancer services and containers with things like AG agents that we've built in to provide new capabilities, easier deployment, and a whole new way of doing availability groups and high availability for SQL Server. You know, I'm a developer at heart. I've been a developer for a while. I was a developer before joining Microsoft, so I'm a big, strong believer in making sure that the database development experience is really world-class for SQL Server. And we've done a lot of work in previous releases of SQL Server to actually make that happen. And in SQL 19, we make that experience even better. So we introduced in SQL 17 the ability to do SQL Graph database data models, and we're enhancing those capabilities by including new T-SQL extensions for things like merge statements, edge constraints, and so forth. You'll continue to see us really enhance this area so that we believe you can take your entire graph model, bring it right into T-SQL, and extend it with the T-SQL language. We now support UTF-8. So if you're out there today using Unicode and you're worried about kind of the storage overhead of that, simply by going to new UTF-8 collations, you can get almost a 50% reduction in storage space for your Unicode character data. In SQL 16, we first came out with the concept of machine learning services built into the database engine with R technologies. And in SQL 17, we enhanced that with Python. Well, we're proud to announce with SQL 19, we believe Java is a new paradigm that customers might want to use. Think about scenarios where maybe you are in an Oracle scenario and you'd like to migrate to SQL Server, but you relied on things like Oracle procedures. We now provide the ability to now do Java programs extended with the T-SQL language. And you see the diagram on the right here that kind of shows you our architecture. The reason this architecture is significant is that while the Java, R, and Python code can actually be extended with T-SQL and executed through a T-SQL procedure, it runs in a unique environment on the same server as SQL Server using what we call our Launchpad service in a way that is isolated in a process point of view so it doesn't disrupt the SQL process. It's performant because these processes can directly communicate with the engine, but it also is secure and governed. So Resource Governor, a great feature that we've had for many years in SQL Server, can directly control CPU memory and I/O processing for these different scenarios. Why don't we take a look at what this looks like for Java and what's possible to use for to extend the T-SQL language. So what I have in front of me right here is a screen with Visual Studio Code showing a piece of Java code I've written. And what we've done is written an example using a function called an n-gram. An n-gram is a paradigm to be able to do word classification for natural language processing. Well, it turns out there's no built-in T-SQL function for n-gram, but Java actually provides a nice platform for that. So you might have a piece of code in Java that looks like this, and we actually have documentation and protocols for how you actually instantiate data that's going to come into this Java routine and how you're going to send results back from this Java routine. One of the unique aspects of doing Java development with SQL Server is you're not going to do a lot of array passing into these procedures. You're actually going to have the ability to accept a query input of rows from a T-SQL query and actually send back a result set. And we have these capabilities with R and Python as well. We now support that with Java. So how do you actually run something like this? Well, from my command line, I actually have a script here where I actually can take the Java code I built, I can compile that code with a Java compiler, and then I'm going to put it into a directory where I have what I call my Java classes. Using Azure Data Studio, I have an example here with a SQL 19 instance where I show you how to run this Java code. Let me point out a few characteristics of this. So first of all, you see here I have a Java class path with a directory right here. This is where I'm going to point the Java classes I built. And then I'm going to use the SP execute external script system stored procedure, which is what we did to supply with R and Python capabilities. And we have a new language type called Java. In the script, I'm going to put the name of my Java class that I'm actually going to run, the Java method for my Java class. And this is the part that's interesting. I'm going to put an input data parameter, which is a query in my SQL Server database. When SQL Server is going to run this script with your Java code, it's going to go take the result of this query and run those results, feed in and pipe that data to the Java program, which it can then accept. And then the Java program is going to run and turn around and spit out a result set of the n-gram result of text data from my table. And this is the unique part I was telling you, where we're not going to pass in a big array of data based on a SQL query. We're going to interact with the SQL engine directly. This allows us to get a much higher rate of performance, and why we actually call machine learning services and Java extensibility built into the database engine itself. So once I've got this set up, I'm going to go kick off. I'm going to run this query, and I'm quickly going to get back my results in an actual table. Now, if you think about this scenario, you could then build a stored procedure on top of this, run it, take these results back, and any T-SQL application that wants to run now this JavaScript can do so through T-SQL through a stored procedure. Now, we talked about SQL Server on Linux being a great compatibility story, choice with compatibility. So it's so simple to be able to take the same example, since it's Java, and run it on Linux. I've got over here a secured shell where I've actually copied my Java classes over to my Linux server. I'm then able to take the same script and simply changing my class path to point to a Linux directory. I can run the exact same script against my Linux server running SQL 19, and I get back the same results. So if you run now your Java scripts and your Java programs on a SQL Server on Windows or Linux, you have the same capabilities because we have those same functionalities together with SQL Server 2019. Let's go back and talk about a few of the things we're doing with SQL 19. As you know, Debbie talked about earlier in this session here, SQL 17 was when we announced our capabilities of SQL Server on Linux and Docker containers with a platform of choice with compatibility. And the SQL Server core engine is the same architecture that runs both on Linux and Windows, but there are some features on what I call the edge of the engine, replication, distributed transactions, and machine learning. Those features did not exist on SQL on Linux on 17. So in SQL 19, we want to make sure those feature gap parities are closed, and we now support all of those functionalities. We also support Open LDAP provider with providers like Centrify, so that the AD authentication experience is much simpler now than it was in SQL 17. And we really believe in the container experience. We've actually now launched, we just announced this at Ignite, the new Microsoft Container Registry, which Microsoft owns that public registry. We are now participating in that. So all of our container images will now be stored on the container registry, but we will continue to syndicate all our containers on popular registries like Docker. And because we now have a Red Hat container image we've built, we're now part of the Red Hat Container Catalog. So you still use your popular public registries to get SQL Server container images, but we'll store this in a common container registry that Microsoft now owns and supports. And then, of course, I mentioned always on availability group experience on Kubernetes. And I just want to comment that you're just seeing the tip of the iceberg. Travis's demonstrations and his discussion of our big data cluster technology are all powered by containers and Kubernetes. And I continue to believe that's a paradigm that we will continue to enhance. At Ignite, for example, my colleague Vin Yu showed with one click of a button how to spin up a SQL Server replication publisher subscriber scenario using Docker Compose and containers. So it's going to provide a whole new paradigm of how we do a SQL Server in the future moving forward. We are a big believer in listening to you and the feedback you have for our product. I've experienced that myself throughout my career at Microsoft, both when I was in support and now I'm in the engineering team. And we've announced in SQL 19 CTP 2.0 just a few small feature sets that were direct connect items that our customers gave us. We call these design change requests that we built in the SQL engine. And whether that's making sure that column store is a first-class citizen in tools like clone database or when you're estimating compression, but even providing little tiny features that actually are very powerful, like being able to look at page resources. Previously, before, customers would see page information inside SQL DMVs and had to go run an undocumented command like dbcc page. We now have built-in functions in the SQL Server engine where you can now take that page information and extrapolate the entire dbcc page header, including the object that goes with that page. And we think that's the kind of type enhancements that customers have asked us, and we're just on the brink of this. You're going to continue to see us throughout the SQL 19 release add more features that customers have been asking us through our feedback system. So that's just kind of a flavor of what we're doing on the engine, both in performance, security, availability, modern database development platform, and with connection items and customer feedback specifically for the database engine. I just want to add one more comment about our tool scenario. Travis showed you some demonstrations, I did as well, of our new tool called Azure Data Studio, formerly known as SQL Operations Studio, that's been in preview for actually several months. I just want to point out a couple of comments about the name because we've had some customers ask us about that. Number one, Azure, I think you need to start thinking of Azure as a hybrid story, and we do. So the Azure Data Studio experience is about exploring data and using data both for SQL Server in a private cloud environment or for SQL Server or other Azure data assets in public cloud environments. This is your overall Azure data tool experience. In addition, we provided extensions with this tool, so the data explorations you see with new data sources or big data clusters all come from the power of using Azure Data Studio, including the amazing experience Travis just showed you with notebooks. And then finally, if you're a Mac or Linux user, this is your preferred tool because it runs natively in both those operating systems. SQL Server Management Studio, we did announce, though, a new preview for it, 18.0 preview, and we still believe in that tool, and we'll continue to enhance and invest in that tool if you're running on Windows and you're a true DBA that wants to just manage and do experiences with SQL Server administration. So we're fully committed to both of these tools, one being a great experience for data exploration, using different type of data sources in a cross-platform environment, and we still believe in enhancing SQL Server Management Studio for those rich DBA experiences when you're running on a Windows client platform. I think you're going to find that SQL 19, we're not done with that experience, and I'd like to turn it back over to Debbie to tell you a little bit about where we're headed down the road and kind of close us out today.
Thank you, Bob. So even though we've just announced a preview of SQL Server 2019, we're not standing still. We actually plan to enhance the preview of SQL Server 2019 every month with monthly CTPs, where you'll see new features as well as feature enhancement and completion rolling out as we gear up for general availability. Some of the places where we're going to continue to land enhancements in SQL Server 2019 are the ability to run SQL Server on the edge. We're going to provide some fit and finish to the brand new big data clusters and data virtualization scenarios. We're going to have some engine enhancements that help with SQL Server performance, as well as some ways to recover SQL Server more quickly when you have an outage. We'll provide additional support for more ways to realize the always encrypted secure enclaves, as well as some additional SQL Server security features that aren't even announced yet. And we'll continue to enhance the engine to align with hardware innovation and make our container experience great. So basically, watch this space. We'll be announcing monthly previews. You can read up on them on the SQL Server blog and in the SQL Server documentation as they come out. So the What's New article will be a great way to keep on top of what's coming in the latest CDPs. Here are some places where you can go to learn more about SQL Server. There's a SQL Server webpage on Microsoft.com at Microsoft.com/SQL Server 2019. There's also a great article, I mentioned the What's New article for CTP 2.0 that's in the docs.microsoft.com article about SQL Server 2019. And if you're interested in getting support for a SQL Server 2019 scenario before general availability, or you would like to try the big data clustering feature, you can go to the early adoption program for SQL Server 2019. There's a link on that Microsoft.com SQL Server 2019 page, or you can go directly to the short link aka.nms/EAP signup. And so now we're going to switch over to the Q&A portion of our show. I hope that you've been entering your questions all along. We're going to stay on the line for a few more minutes and work to answer as many of those as you'd like to enter. And while you're entering those questions, I do have a few frequently asked questions that I'm going to answer with my fellow presenters. These are some things that we've been hearing from customers at our early presentations and our Ignite event, and we wanted to go ahead and get those out of the way and share some answers with you. So I'll aim the first question at Travis. This is one we've been hearing a lot. How does SQL Server Big Data Clusters work in Azure?
Yeah, so SQL Server 2019 Big Data Clusters can be deployed on a managed Kubernetes service like Azure Kubernetes Service. And there you get all of the capabilities of the SQL Server 2019 Big Data Cluster, including the management experience there that you can access just through a browser. The other option, if you need even more control over how things are deployed, is to stand up some VMs inside of Azure using Kubernetes to deploy a Kubernetes cluster inside of VMs and then deploy the SQL Server 2019 Big Data Cluster on top of that. And going forward, our plan is to also support OpenShift. And once we have OpenShift support, then you could deploy on OpenShift on Azure.
Thank you. And then I can take the next question, which is what is the pricing and licensing for SQL Server 2019? And the pricing and licensing for our releases is something that we don't announce until we're getting ready to launch them. So I don't have anything for you right now. What I do want to tell you, though, is that we are building both the engine enhancements that Bob talked about and the big data capabilities that Travis talked about into SQL Server. So customers who have existing SQL Server licenses with software assurance will have access to these new features when they upgrade. And we're continuing to build in this value with our everything built-in pricing and packaging philosophy so that you can take care of even more of your data workloads with SQL Server. The next question, I can also take, when is this going to be released? We haven't announced a release date yet. However, this will be announced during 2019. So, watch this space. As I mentioned, we're going to be releasing additional public previews monthly for a little while. And then you'll know when it's coming because we'll have some release candidates. And we look forward to bringing this new product to you next year during 2019. The next frequently asked question I'm going to aim at Bob. The question is SQL Server the same on Windows and Linux in SQL Server 2019? And I frequently get this question from customers who know that there were a few functional areas missing in SQL on Linux in 2017, and they want to see which gaps we've closed. So I'll hand that over to you, Bob.
Yeah, thanks, Debbie. Actually, I get the question more of, should I run SQL Server on Windows or Linux? And my tongue-in-cheek reply is yes. And the reason I say that is because, first of all, there's a compatibility story here. You can take your database that you back up on Windows and you can restore it on Linux or vice versa. So the databases are completely compatible. And as I showed earlier in this presentation on SQL Server 2019, the feature set that we've built is now completely closed. So things like replication, distributed transactions, machine learning services, those things now work on both platforms. And then finally, it's about performance. People ask me all the time, which one's faster? And quite frankly, based on our testing and customer feedback, it's all based on your workload, but the performance is very similar. We've seen some workloads run faster on Windows, some on Linux, obviously some depend on your hardware. But quite frankly, I personally tell customers that performance should not be your determination of running on which operating system, Windows or Linux, for SQL. It should be more based on your choice. In your organization, is Linux a standard or something you want to move to? Is that a preferred platform? Or is Windows the preferred platform in your environment? So we kind of feel that we've built that message I've given you, Debbie, before in this talk, and that it's a platform of choice with compatibility.
All right, good answer, Bob. And then one other question that comes up also, again, licensing focused is, we talked a little bit about how SQL Server works on containers and how we're expanding the HA capabilities through containers managed by Kubernetes. And the question that we get in relation to this is, how do I license my environment for containers? The very short answer is that we think of containers as being pretty similar to virtual machines. And so many of the rules for licensing SQL Server for virtual machines are the same for containers. But if you'd like to read the detailed write-up of how SQL Server is licensed on containers, how we think about the cores associated with a container versus the hardware, et cetera, you can actually take a look at the current SQL Server 2017 licensing guide that's available on the SQL Server 2017 page. So all you would have to do is go to Microsoft.com/SQL Server 2017, choose the pricing tab, and the SQL Server licensing guide is what you need. Or you can simply go to your search engine and look for SQL Server 2017 licensing guide. So with that, we've come to the end of our frequently asked questions portion. As I mentioned, we'll continue to stay on the line for a few more minutes to take questions through the QA chat window. And thank you very much for joining us for the SQL Server 2019 preview webinar.